This video is about creating a table of values and identifying the slope and y-intercept when putting an equation into function form. So how do we determine if a point is a solution? So for yes, the number on the one side is going to equal the number on the other side. So for example, 7 might equal 7. If we have a no, the numbers are not going to equal. So for example, we would have 5 does not equal -3. So in the first example in this box here, we're going to put 5 in for x and -1 in for y. So 2 times 5 plus 3 times -1 equals 7. That gets us 10 minus 3, so 7 equals 7. So this would be a yes. In the second example, this is our x, this is our y again. So 4 times -3 plus 2 times 2 equals -9. So we would get -12 plus 4 equals -9. When we do that, we only get -8, and -8 does not equal -9. So this would be a no. So let's look at two more examples. So in the first example, we have our x coordinate, we have our y coordinate. So 5 times 1 minus 2 times -1 equals 7. So in this case, we have 5 plus 2 equals 7, and 7 equals 7. So yes, this ordered pair would be a solution. In number 2, with my point, I have 3 times 2 plus 4 times 1 equals 9. So I would get 6 plus 4 equals 9. In this case, that would be 10, which is not equal to 9, so it would not be a solution. We can also use graphs to figure out if a point is a solution. So below is our graph of the equation y equals 2/3 x plus 6, and we want to justify our answer algebraically to see if it's a point or not. So the first one is 0, 6. So I go to 0, 6, and 0, 6 is on the line, so yes, it's a point, and we can even test that in our equation with our x, y. So 6 equals -2/3 times 0 plus 6. Well, -2/3 times 0 is just 0. So we get 0 plus 6, which means 6 equals 6. And this is a true statement. Our next point is 3, 5. So we'd go over 3 and up 5. And in this case, it's not on the line, so it would not be a solution. And we can also test to make sure. So we would have 5 equals -2/3 times 3 plus 6. -2/3 times 3 is -2, plus 6 would only get us 4, and those are not equal, which is why it would also not be located on the line. Our next point is 6, 4. 2, 3, 4, 5, 6 over 4. This is also not a solution because it's not on the line, and we can test that in our equation again. So 4 equals -2/3 times 6 plus 6. So -2/3 times 6 is -4. -4 plus 6 is just 2. And 4 does not equal 2. So again, that would mean that that point's not on the line. It's not a solution to the function. Thinking back to what we talked about the past couple of days, what's the special name for the point 0, 6? That is also called our y-intercept. What is the rate of change of the line? So for the rate of change, pick any 2 points. I'm going to pick these two. How many did I go up or down and then over? Well, my line is slanting down, so I went down 2 over 3. So my rate of change or slope would be -2/3. So how can we graph a function rule ourselves? So the first thing we want to do is we want to make sure that the equation is in y equals. Then we want to choose a few values of x to make a table, and then we're going to plot those points and connect them. So the first example we have is y equals 2/3 x minus 2. So when I'm picking my x coordinates, I want to be careful. Because this is a fraction, I want to look at the number in the denominator, and I want to choose multiples of that. So multiples of 3, I could have -3, 0, 3, and 6 to get my points. So I'm going to take those numbers, I'm going to put them into the equation. So 2/3 times 3 is -2, minus 2 gets us a y-coordinate of 4. 2/3 times 0 is 0, minus 2 is -2. 2/3 times 3 is 2, minus 2 is 0. and 2/3 times 6 is 4, minus 2 is 2. So now I have my points in my table and I can graph them, and then I can answer these questions. So first I'm going to graph my points, so -3, -4, 0, -2, 3, 0, and 6, 2. And I can connect those lines. So find the rate of your function rule. So remember that the rate of the function rule is also known as the slope. It's what's in front of the x, so it'd be 2/3. In the function rule, what's my starting point? So the starting point is the number by itself, 0, -2. When I look at the graph, what is my slope of the graph? So I'm going to go from one point to another. I went up 2 and right 3. So my slope would still be 2/3. What is the starting point of my line? So remember, the starting point is also the y-intercept. It's where it's crossing the y-axis, and that point is at 0, -3. And then for part E, use one more point on your graph from your slope. So we know our slope is 2/3. So from the last point, I'm just going to go up 2 over 3, and then I can continue that line. So number 5, use the table to graph. So first we need to get this into y equals. In order to get into y equals, the x needs to go the other side. So since it's a positive x, we're going to subtract x from both sides. And we get y equals -x plus 3. Now, because x is not a fraction, we can pick any values we want for x. I'm going to stick close around to 0, so I'm going to say -1, 0, 1, and 2, just so I make sure that my points are probably going to fit on the graph. So -1, we're going to put in for x, so -1 becomes +1 plus 3 is 4. -0 plus 3 is 3. Negative times 1 plus 3 is 2. And negative times 2 plus 3 is 1. So I'm going to plot these points. So I have -1, 4, 0, 3, 1, 2, and 2, 1. And then I have my line so far. So what is the rate from the function rules? Remember, the rate is the number in front of the x, which is negative. So we would say -1, or we could say -1 over 1. What's the starting point from the function rule? So what's the number by itself, which in this case is 0, 3. What is the slope of the line? So I'm going to pick 2 points. I went down 1 over 1, so my slope is -1 over 1. And the starting point is where we cross the x-axis, so it's 0, 3. If I want to add one more point to my line from either point, so I'm going to go the farthest one on the left, I'm going to go down 1, right 1, and I can add a point that extends that line then. So if I redraw the line with that point, it's just extending it longer. So number 6, we need to solve for y first. So the first thing to do in order to solve for y is we are going to subtract 2x from both sides. -4y equals -2x minus 20. And when I divide by -4, I get y equals 1/2 x plus 5. So again, there's a fraction, so I need multiples of my denominator. Well, if my denominator is 2, some multiples I could pick would be -2, 0, 2, and 4. So I'm going to put those points into the function rule. So 1/2 times -2 is -1 plus 5 gets us 4. 0 times 1/2 is 0 plus 5 is 5. 1/2 times 2 is 1 plus 5 is 6. 1/2 times 4 is 2 plus 5 is 7. So I can plot these points again, and then I can answer the question. So I have -2, 4, 0, 5, 1, oops, 2, there we go, 2, 6, and 4, 7. I can connect those points. So question A, what is the slope from your line, the function rule, and the graph? So if we look at the graph, we went up 1, right 2. That's the same slope that's in our function rule. And if I pick 2 points in our table, we changed by 1 to get from 4 to 5 and by 2 to get from -2 to 0. So my slope is 1/2 for all 3 things. What is the starting point? So the starting point is where we're crossing the y-axis at 0, 5, 5 in the table, and 5 in the function, 5 in the 0, -5 in the table, and 5 in the function rule. So our starting point is 0, 5. If I want to add one more point to my graph, I would go up 1, right 2, because I'm using that slope, and then I would connect my line.